system. Oh, that was awesome. You solved a system of equations by elimination, and you already had opposites, or very close to opposites. Maybe they just needed to have a sign changed or something, okay? But today, you're not going to have opposites. So you're going to have to multiply in order to get opposites. So if you look at the steps here, they're very similar to yesterday. Line up your variables. But number 2 says multiply one or both equations by a number to get opposite coefficients for at least one variable. Okay? So that's the new piece. 3, add or subtract equations to eliminate. And 4, substitute the value from step 3 into one of the original equations and solve. So, looking at number 1, again, yesterday if you did this problem, you would say, well, neither one of them have opposites, and neither one of them have close to opposites. So today, what you're going to look at is you're going to say, well, can I multiply one of those equations by something in order to get opposites for one of the variables? So if you look at x in the first equation there, you have 6x. Negative 2 is not the opposite of 6, but what can I multiply negative 2 by in order to get the opposite of negative 6? 3, right? Okay, so what I'm going to do is I'm going to keep this top equation exactly the same, but the bottom equation I'm going to multiply by 3. And what you do to one side, you have to do to both sides. So check it out. This 3 goes to all 3 pieces of this equation. So we get negative 6x minus 9y equals negative 15. For this one, you would want it to be positive 3 because you want to get a negative 6 and the 2 is already negative. Because now, in the top equation we have 6x and in the bottom equation we have negative 6x, so now we do have opposites. So you want to multiply by something that's going to give you opposites for either the x's or the y's. Okay? Alright. So now that we have opposites, it looks just like yesterday. We can add straight down. X's cancel. We get negative 4y equals 4. So y equals negative 1. Plug that back in to either original equation. It does not matter which one, as long as you plug it in for y. Bless you. Question? No, you multiply by some number to get an opposite. So opposite of 6 would be negative 6. So can I multiply the negative 2 by something to get negative 6? Yes, 3. So that's how you'll pick that. So we end up getting 4 for x. 4, negative 1 is our solution. So if you graphed these two lines, they would intersect at 4, negative 1. If you plugged it back in, you would get a true statement for each of those. Is the solution. All right. Number 2 is super similar to number 1. What are we multiplying by? 3 on the top equation or the bottom equation? Bottom. It's going to give us a negative 6 again, which cancels with the positive 6. So, just like in number 1, the top equation staying the same. The bottom equation, however, is going to be multiplied by 3. So you get negative 6x plus 9y equals negative 15. Again, make sure you multiply all pieces by whatever the number is out on the outside of the parentheses. Add straight down because you have opposites for the x's. You get 7y equals negative 14. So when you divide, you get negative 2. And again, you can plug that in for either variable. Either equation, as long as you're plugging it in for y. So we get 6x plus 4 equals 1. If I subtract 4 from both sides, I get negative 3. And if we divide by 6, we have negative 3 divided by 6, bless you, which is negative 1/2. Be careful there, it's not negative 2, it's negative 1/2, because the bigger number, the 6 is on bottom. Questions? All right, let's look at number 3. What's different? What do we need to do first? Yeah, we have to change the order, right? We have to stack them up. All right, so I'm going to keep the top equation as it is, just because that's my personal preference. X, y equals a number. The bottom equation, I'm just going to move that 5x over. So I'm going to subtract 5x from both sides. And get negative 5x plus 9y equals 5. With me so far? Okay, so what would we multiply by? Can we multiply one of the equations by something that is not a fraction to get an opposite? No. So step number 2 above says multiply one or both equations by something. I typically pick the variable that has the smaller coefficients. So in this particular problem, I would work with x. You don't have to. You can work with y, but I would work with x. What number can both 3 and 5 go into evenly? 15. So in order to get 15, what would I multiply the top equation by? And what would I multiply the bottom equation by? Okay? And now you have opposites for x. That's why you multiplied both of them by something, because now you have 15 and negative 15. They eliminate, they cancel, they give you 0 when you add them together. Get negative 8y equals 40, which means that y is negative 5. Plug that back into either equation. It does not matter which equation, as long as you're plugging it in for y. And solve for x. Remember, you should be doing this on your own and just checking with mine. Copying mine is not giving you the practice of solving equations. Thanks, I kicked those over. Yep. Yep. We good? Fraction time. Yay. What gets rid of a fraction? If I have like 2/3 x equals something, how do I get rid of the 2/3? Multiply by the reciprocal. That's what we're going to do here. We are going to multiply by the reciprocal. What variable do you guys want to get rid of, x or y? You want to get rid of y this time? All right, let's do it. Okay, this is different from second and third hour. They got rid of x, so let's get rid of y this time. All right, I'm going to change my pen real quick. I'm going to go to a little bit thicker so you guys can see what I'm doing here. Okay. If I want to get rid of y, that means that I want to get rid of the 3/4. What is the reciprocal of that? 4/3. And I want to get rid of the y in the bottom equation as well, what's the reciprocal of that? 3 over 1. Or just 3. Okay? Now, when I look at that, is one of them going to be positive and one of them going to be negative? Yes. So it's going to cancel them out. We're good to go. All right. So let's go ahead and multiply this out. When I distribute here, you multiply fractions straight across. So I would have 12 over 15x. I'm not going to reduce yet. I will come back and reduce. I want you to know where the numbers came from. Here, positive times a negative is a negative. And the 4 and the 3 would cancel, right? Because you have 12 over 12, which is just 1y. That's why we did it. We wanted to get rid of that fraction. Equals, if you put this over 1, 4/3 times negative 3, positive times a negative is a negative, you get 12 over 3. Yes, we can reduce. But let's just finish this off first, okay? Let's multiply this 3 over 1 by everything in the second equation. So we'd get 6 over 5x. 3 over 1 times 1 over 3 cancels, and you just have y. Equals 24. With me? Okay. If you want to reduce these, you may. 12 over 15 can reduce by 3 and you get 4 over 5. And negative 12 divided by 3 is just negative 4. Nothing really reduces in the bottom one. Okay. I see that we have a y and a negative y. Those are opposites. We can add straight down and eliminate them. That's why we did it. Perfect. If we add these straight down, the y's cancel, but what do we get for x? What's 4/5 plus 6/5? 10/5, which is 2. And negative 4 plus 24 is 20. So when you divide, you get x equals 10. That's just x. We need y. So we plug it in for x to solve for y. Doesn't matter which equation, I'm going to pick the top one. 3 over 5 times 10 over 1, because that's x. Minus 3 over 4y equals negative 3. Well, 3 times 10 is 30 divided by 5, because you'd have 30 over 5 is just 6. I would subtract 6 from both sides, and I get negative 3. And how do we get rid of a fraction? Multiply by the reciprocal. So we're going to multiply both sides by negative 4 over 3. Y equals negative times a negative is a positive. 3's cancel, and we just have 4. 10, 4. Yep. Okay, so I did make that change here. This was supposed to be a negative 3, so that would make that negative 9. It changes things just a little bit because of that little negative. Okay, so define your variables and write 2 equations. And here they give us 2 totals. So when they give you 2 totals, you're going to have something plus something equals something. And the other one likely is going to be the same setup. Not always, but sometimes. If we multiply by negative 2 on the top, we're going to get negative 6x, and if we multiply by 3 on the bottom, we're going to get positive 6x, so that's going to cancel out our x's and allow us to solve for y. So let's do that. So if you plug that back in, you just want to know the cost of